So you already know what the quadratic formula is. And the thing we're talking about today is the discriminant. Now the discriminant is this part right here. So we're going to use a little triangle for discriminant. Discriminant equals b squared minus 4ac. And this is really cool because it tells you how many solutions your quadratic equation has. If the discriminant is greater than 0, you'll have 2 solutions. Now if the discriminant is equal to 0, you'll have 1 solution. And if the discriminant is less than 0, you'll have 0 solutions. Positive, 0, negative. Now, if we start with the negative one, it's really obvious why this happens. If this bit under the square root is negative, you're trying to find the square root of a negative number. There is no square root of a negative number, at least not in the maths that we're doing, so we can't get a solution, 0 solutions. If there is 0 under the square root of 0 is 0. And if we're adding or subtracting 0 from something, the something is still going to be there. So we're only going to get one answer. If, however, this number under the square root is positive, then we'll be able to add the positive thing and we'll be able to subtract the positive thing. So we'll get 2 solutions. How many x-intercepts does y equal x squared plus 2x plus 4 have? We can put it into the quadratic formula and try to find them, or we can just put it into the discriminant. Now, the discriminant is equal to b squared minus 4 times a times c. And when we do that, we get 4 minus 16. We get negative 12. The discriminant is less than 0, therefore we get 0 solutions. So we get 0 x-intercepts for this quadratic equation. It's really straightforward. Now this is a slightly different question. It's a bit tricky, but we can get there. We need this to have 2 solutions. Now, for it to have 2 solutions, what do we know? We know that the discriminant needs to be greater than 0. We know that the discriminant needs to be greater than 0. Now, we know that the discriminant is equal to b squared minus 4ac. So let's substitute b squared minus 4ac, b squared minus 4ac, for our discriminant. We need that to be greater than 0. Now, subbing in our values, we've got negative 4 squared minus 4 times 2, and the c value is p. And we need that to be greater than 0. Now that's 16, that's negative 8p, and we need that to be than 0. And then we can rearrange this. So negative 8p needs to be greater than negative 16. And then we divide by negative 8. Now when we divide by negative 8 in this inequality, the inequality is going to shift. So we're going to end up with p is less than negative 16 divided by negative 8. So p needs to be less than 2. Alright. So, what have I just done? Determine the values of p such that this has 2 solutions. As long as p is less than 2, this will have 2 solutions. Of course, you can satisfy yourself by putting this y equals 2x squared minus 4x and then putting various values in for p and seeing what those equations look like. Now, there is one more thing I can do with the discriminant. If the discriminant is a perfect square, 4, 9, 16, 25, 36, 49, etc., the solutions will be rational. They'll be able to be expressed as a ratio, as a fraction, or as a whole number. Why? Because this is the quadratic formula, right? And this is the discriminant in here. If we put a square number here, like, perfect square, like 4, 9, 16, 25, then what we get is a rational number plus some rational number divided by some rational number. A rational number divided by a rational number will be a rational number. Whereas if we put a number like 7 in here, which is an irrational number, we'll have an irrational number on the top divided by a rational number on the bottom. And an irrational number divided by a rational number is an irrational number. So this gives us information about whether it will be a rational solution or an irrational solution. So here's a very challenging question here. Show that the solutions of this equation, this is just a number, m minus 1 plus m plus 2, are rational for all rational values of m. Okay, a rational value of m. If we want m to be a rational value and we want all of them to be included, we can just say let m equal p over q. If it can be expressed as p over q, then it's rational. Let's put p over q into that equation. So now that we've done that, we can find the discriminant, right? Because we want to know, it's to show that the solutions of this are rational. We need the discriminant to be rational because then the solutions will be rational. Now, to find the discriminant, we know that we use b squared minus 4ac. Now, the b value is all of that. The a value is here, and the c value is all of that. So let's put that, and that into our discriminant formula. It's getting pretty hectic here. We've got this as our b value, we need to square it. Now if you're squaring a bracket, remember it needs to be the bracket times the bracket and use like the FOIL method to square it. And then we're going to multiply this by this to get positive 12, and then multiply 12 by that and by that. There's a lot going on here. Alright, so I've written this out and I'm kind of finished now, even though you might not see it. So what we have is the discriminant equal to this, which is a rational number, minus a rational number, plus a rational number, plus a rational number, plus a rational number. There is nothing but rational numbers there. If you add rational numbers to rational numbers to rational numbers, guess what? You get a rational number. Now, because all of those are rational numbers, then we can say that this is a rational. The discriminant is a rational number, and therefore the solutions will be rational numbers. All right, that's a bit of an extension one there. We're looking at the discriminant, we're looking at the number of solutions, and we've also seen that if you've got a perfect square, you can tell whether it's going to be rational or not.